Okay, here we go. So we're gonna start off like kind of simple, and these are gonna build up. All right. So just kind of giving you a heads up. Like the first one or two might feel like real easy, but as we go through, it might get a little bit more challenging. Okay. So here we go. Example one. All right. So here's the scenario. Okay. Your family. Let's just pretend you don't have running water or something. Okay. So your family needs 2 gallons of water this week. Okay. But you don't want to buy more than 8 gallons. Okay. Let's just say that you don't have enough room to put them. Okay, so you don't want more than 8, but you need 2. Okay. So what we're trying to do is write an inequality representing the possible gallons of water you can buy. Okay. All right. So pretty straightforward. Okay. You have a situation here where you have basically a minimum and a maximum. You need 2 gallons of water for the week, right? To wash dishes, to shower, to drink, whatever it might be, okay? But you don't want to buy more than 8, okay? So 2 becomes like your minimum. I need to have at least 2. But I can't have more than 8. I can have exactly 8, but I can't have more than 8, okay? Because then I have storage issues. I have nowhere to put it, okay? Or someone might come along and steal it. Right? So you want to write an inequality that represents the possible gallons of water you can buy. Right? So kind of in your head, think about this. Like you could buy anywhere between that range, between 2 to 8. Now, how do you write it as an inequality? Okay, so here's kind of where we talk about this part. The first thing you have to do is define a variable. Okay, with any kind of word problem, you need to let your unknown be represented by some sort of variable. Okay, so that first part, part A, define the variable regardless of how obvious it is. Okay, define the variable. Okay, and in this case, what's our unknown? Because you don't know exactly how much you're going to buy yet, right? What would be the unknown here? What could be the variable that we define? G. And what do you want G to represent? The gallons, okay? The number of gallons of H2O. Okay, water. All right. All right. So let's set G up, right? We're going to write an inequality here. You have a minimum and you have a maximum, and you have to you have to stay within those bounds, right? So what kind of inequality do you think we're writing here? Do you think about what we've had? We have and we have or. What do you think we need in this situation? What do you think would work best? And inequality, yeah, because I need more than 2 and less than 8, okay? Or, yeah, less than that amount, right? So let's start with G here, okay? All right, G, the number of gallons of water of H2O, number of gallons of, that's redundant. The number of gallons of water, okay? What was my max here? It's the maximum. I can't go past it. It was 8, right? Okay, now, therefore, what do you think the relationship is between G and 8? G is less than. Is it only less than? or equal to, right? I kind of gave it away when I said that I can buy 8, but no more than that. So when I see the key word, I don't want to buy more than, right? I can still have exactly 8. Okay. So if that's the case, then that's less than or equal to. Okay. All right. Now I want to keep this as a nice sandwich, right? So I don't want to rewrite another inequality. Let me just work with what I have here. Okay. Now I know that the minimum value was 2, right? Okay. So then in that case, what's the relationship going to be between 2 and G? We want G to be what? The number of gallons we want it to be greater than. Can I have exactly 2? Yeah, I need 2. I need 2. I could get by with 2. That's my bare minimum. So I need exactly 2, but I can always have more. Okay. So then that's our inequality right there. Okay. So like I said, it's not too bad. Like you can actually literally just think G is going to be somewhere in between 2 and 8. Okay. And then just think about what is the relationship between the gallons and the maximum and then the gallons and the minimum. Okay. All right. If I want to draw out a number line here, 2 and 8. Okay. Do you think this is going to be one of those tricky cases where there's no overlap? Right, that special case we looked at yesterday or Friday. Nah, right? It's water, right? We want somewhere in the middle, right, between 2 and 8. So in this case, right, we have a solid circle, and you shade everything in between. Okay, what's my interval going to look like? Let's practice. Bracket 2, comma 8 bracket. Okay. I feel like you guys are good on this bracket stuff when it's an and problem and it's shaded in the middle. I looked at your quizzes. The biggest issue was mostly kind of rewriting it. You guys put whatever was on the right, you put it on the left, and whatever's on the left, you put it on the right. So you kind of switch things around. A lot of you guys didn't simplify your fractions, little stuff like that. Okay. Questions on this first one? Right, pretty simple, right? So this is kind of a baby one in this case, all right? You have a max, you have a min, and then my variable is just the number of gallons of water I can buy. Okay, there's nothing really special about it. Okay, here we go. Let's take a look at example number 2 now. All right. Okay, so in a certain restricted Air Force base, have you guys heard about that Area 51 stuff? Okay, so let's just say AKA Area 51. Okay. Okay, airplanes must fly below 10,000 feet or above 15,000 feet. Okay. Write an inequality. That models this situation. Okay. Okay. So just like in example 1, what's the thing I need to do before I start writing any inequalities? I gotta define a variable. Yeah, I need to make sure that my audience, whoever's reading my problem, understands that I know what that unknown is. Okay, so we define a variable. Any ideas on what we want to call it? What we want to define it for? H for height of what? Height of airplane. Okay, good enough. Okay, height. All right. Now, in this case, think about what we have. Okay, you have a restriction. Okay, the planes can fly below 10,000 or above 10,000 feet. What kind of compound inequality are you writing? Or, right? It tells you in the problem, right? So you just got to read it. As long as you can read it, you'll see like, hey, I'm looking at an or inequality. Okay. I obviously cannot be in between the intersection between 10 and 15. That's the space where I'm not allowed to fly. Okay. All right. Okay. So now let's go ahead and talk about it. Okay. So we have a first one here. We have H, and H has a relationship to 10,000 feet. Okay. Now what is that relationship? We have to be below it, right? So that means that the height of my airplane has to be less than. Can I be exactly at 10,000 feet? What do you guys think? What do you think? You're shaking your head no. Why no? You were like, why can't we say that? Can we include 10,000? Right? Can we fly at 10,000? It has to be below that, right? That says below. I must fly below 10,000 feet. Okay. All right. Or okay. Now we have another relationship here. We have H and we have 15,000. And what's the relationship there? Above. Therefore, what inequality do we want? Greater than, right? It's above, greater than. Okay. So those are my restrictions. Okay, I can be below 10,000 or above 15,000. It doesn't say that I can be at 15,000, or it doesn't say at least 15,000, right? Above or below, strictly. Okay. All right. So this would be pretty simple to draw. Okay. Number line. Let's call this 10K, 15K. You forgot it? Okay. All right. All right. So at 10,000, open circle, and I shade to the left. Okay. Now, let's think about this. Right? It's an airplane. Do you think do you think that your interval would be from negative infinity to 10,000? It's an airplane. If we were writing an interval, right? Yeah, like from zero, probably, hopefully not zero. You don't want it flying at zero, okay? Um, and then on the other end, right? Again, not because it's a realistic scenario. We're not talking about just numbers here. If it was 15,000, do you think this is going all the way to infinity? No, I don't know what the limit is for planes, but I'm sure at some point they don't work because you're in like outer space. So let's just say 45,000 feet. I don't know. I don't know. I don't know enough about planes. Okay, but right, if we were, that's why I'm not gonna write the interval here. But right, just in case. Okay, let's be smart. You don't want this going all the way to negative infinity. You can't have a plane flying below Earth. Okay. All right. Okay. But in another scenario, I will give you like something that you can actually draw an interval for. Okay. All right. Questions so far? Okay, so pretty simple, right? You have to keep in mind that if I'm asking you to write an inequality, make sure you understand, is he asking me to write an and inequality or an or inequality? Okay, one or the other. Okay, all right. Let's take a look at example 3. All right, so this one's a little more involved. Okay, anybody been snowboarding before? Skiing, water skiing, skateboarding? Yeah, okay. All right. So with snowboards and skis, the skis have to go according to your height. They can't be too big or too small. Because unless you're an experienced rider, then you get them really tall on purpose because they're more for speed. Or you get them really small for control. So when you're starting off as a snowboarder, a lot of times they tell you that the board needs to be between your collarbone and your chin. So if you think about it, it's really only about that much of an error between how big the board can be. If you have a board like up to your like eyebrows, that's way too big for you because it's going to be too hard to control when you're just learning. So you want a smaller board. If it's too small, then that's also a problem because it's just not proportional. Okay, so if you ever go to the mountains and you want to snowboard, they'll tell you like somewhere between your collarbone and your chin. Okay, so that's kind of what this problem is about, and that's kind of where I got the inspiration for it. Okay, so a snowboard shop. Okay, carries skis. Okay, and there's different rules for skis than it is for snowboards. Okay, so they carry skis that are between 150 centimeters and 220 centimeters long. Okay, they recommend that the skis be 1.25 times longer than your height. Okay, so the skis are going to be bigger than you regardless. One and a quarter times. Okay, so if it was one times your height, it'd be exactly the same height. One and a quarter, it's like a quarter of your height added to the skis. Okay, so for me, skis are probably about this tall. Okay, so here we go. Write an inequality that can be used to find how tall you need to be to rent from the shop. Okay. All right. So this might not be the shop for you, right? If you're too tall or too short, they might not have your size. Okay, so this is why we're doing this. Okay, so we're looking for a variable to define, right? In this case, what do you want the variable to be, and what should it define? Think about what it's asking. Any ideas? The height, yeah, of what? The ski or the person? Of the person. Okay, we're looking for the height of a person. So, do you want to use H, X, F? What you got? Give me a letter. T, T, T. Okay. T for height of person. Okay. All right. In what? Centimeters. Okay. What did I forget to do in part two? Yeah, it was the height of the airplane in feet. Okay. Because we're talking about different units, right? So the height, I should have gone back for number two. It should have been the height of an airplane in feet. And for number three, this should be the height of a person in centimeters. Okay. All right. Okay, so we have a couple of relationships here, right? We have skis that are between 150 and 220 centimeters long. Okay, what kind of clue does that tell you there? What kind of compound inequality? And or? And? What do you think? And, okay, kind of, right? It tells you right here, I have skis that are 150 centimeters and everywhere in between up to 220. I don't have skis smaller than 150 and I don't have skis bigger than 220. Okay, so I'm kind of stuck in between this range in the middle. So think back to the picture. If it's somewhere in the middle, it's got to be some sort of and inequality. Okay, all right. So in that case, right, let's start building from the edges towards the center. Okay, because we don't really know how to apply this quite yet. Okay, because the other clue here is that the skis need to be 1.25 times longer than your height. Okay, so I know that, hey, I'm kind of sandwiched in between these options. Let me go ahead and say, okay, I got 150 on my low end and 220 on my high end. Okay, okay, I know for regardless, my variable has to be represented somewhere in the middle. Okay, now it's not just going to be the variable itself. Okay, because in this case, if you were to start drawing inequality signs, you'd be saying that it's okay if your height is 220 centimeters or between 150 and 220. And that's not necessarily what the problem is saying. Okay? What else do we know? What other piece of information about your height? Yes. Exactly, right? So the skis, which is these measurements, okay? The skis need to be 1.2 times longer than your height. So what do I need to include here next to t? 1.25. Yeah, I need to multiply 1.25 times t, right? So this will give me a better indicator, right? So 1.25 times my height, that has to be between 220 and 150. And then if I solve for t, then that'll tell me my height, okay? So what's the relationship here between 125t and 220? Is it less than, or equal to? Less than or equal to because they have skis that are exactly 220, okay? And then between 150 and 125t, 1.25t, yeah, right. We want this to be greater than 150, right? Greater than or equal to. Let me scroll up. All right. So real simple, right? We solve for t, we divide everything by 1.25. Okay, so let's go ahead and do that. Okay, most of you should have some calculators in front of you. Help me out. Give me 150 divided by 1.25. What do we get? 120. That looks like a 6. Okay. And what's the other one? 176. Okay. Oh, did I draw that twice? Yeah. Okay. All right. Cool. So inequality. Draw my graph. I got 120 here, 176 here. Close circle here, and I got everything in between, right? So if you're in that height range between 120 centimeters and 176, they got your board size, they got your ski size. Okay. Questions there? Okay. All right. All right. Let's step it up. Okay. All right. Example 4. Okay. So I have a band, and we're gonna record some music. The name of our band is called Samoza's Band. I tried learning how to play the guitar in high school, and the only thing I ever learned how to play are just like a bunch of intros to a bunch of songs. So like I could never play one song all the way through. It was like the beginning of like a Metallica song, the beginning of a Blink-182 song, the beginning of some other song, La Bamba, things like that. I could never put a whole song together. I never learned how to play chords. I just learned from like finger taps. So I would go online to ultimateguitartabs.com and I would just like read the tabs and that's how I memorized it. But never learned how to play anything. So let's pretend I made it big and famous. Okay, so the band is going to record an album. Okay, the recording studio charges $225 a day for the facilities, for use of facilities. Okay, and $80 per hour for the sound engineer. Okay, so the guys who work the what do you call them? It's like what Dr. Dre does. And he produces, right? Like that big table where they slide things around. All right. All right. So I have saved up $400. Okay. But if the band puts all their money together, they have $700. Okay, total. We're gonna write an inequality that models the number of hours the band can rent out the studio. Okay. Now let's just say we're only gonna rent it out for the one day. Okay. All right. All right. So that's a lot, right? It's a lot of information. Okay. Let's go through and kind of dissect it little by little. Okay. So regardless of what I'm doing, okay, the studio is gonna charge me $225 flat for the use of the facilities, whether I use it for like a second or I spend the whole day there. Okay. So $225. And an additional $80 per hour for the sound engineer. Okay, so nobody in my band knows how to do any of that stuff, so I have to hire somebody on to be there, mixing at the tables, whatever. Okay. I have $400 saved up. Okay, but if my band puts all their money together, in total we have $700. Okay, so we want to write an inequality that models the number of hours that the band can rent out the studio. Right, we want to know like how many hours can we be in there, what's my minimum and what's my maximum number of hours. Okay, so that I don't go over the 700 because then we won't be able to pay. Okay, but I have the 400 and I want to use them up. So the first thing here to think about is how is this going to be charged, right? If I wanted to write, let's start with the sake of like how would I write it? Let's say I was doing an equation. Okay, what do I know I'm paying for short? $400. How much? I have $400 saved up to use, but am I paying 400 for that one day? So I had the 225, right? So the 225 for the facilities, let's start there, okay? And before that, actually, before I forget, what's my variable here? It's H. And what's the H going to stand for? Yeah, number of hours in the studio. Okay. Okay. So now this is where I want to start writing that initial kind of, not necessarily the full equation, but part of it, right? It's like, what's my initial, what's my starting point, and then how much am I adding on every hour, right? It's like, what's my growth per hour? Okay, so if my initial is 225, okay, I need to add on, what could that expression be to represent the $80 per hour? I know it's 225, but I got to add on something. 80 what? 80H, that's right, 80H. Okay, because as every hour increases, $80 is going to get multiplied by the number of hours, right? 1 hour, then times 2, then times 3. Okay, now this amount, right? The 225 plus the 80H, right? All of the money that I spend, what's the maximum number I'm allowed to spend? It's a 700, right? I can't go past that because my band has no more money. So it's the 700. Okay. What's the relationship here between my expression and this quantity? Less than or equal to. Yeah, I could hit the exact minute that I need to stop and then cut it, and then I owe exactly the 700, and my band can pay it because that's how much we have. Okay. Now I want to make sure I get some time in the studio. Okay, what's the minimum? Let's say my band doesn't want to pitch in and it's just on me. It's the 400, right? That's where the 400 comes from. Okay. Now, what's the relationship there? I want this amount to be what? I, I want this to be less than or equal to 400? Greater than. Because I'm good spending those 400 bucks. Like, I need to get some time in the studio. So if it's all me, I'm willing to put the full 400. Okay. So in this case, I want to be greater than or equal to 400. Okay. I could spend just barely 400 because nobody else pitched in. Okay. All the way up to the 700 if we pull all our money together. Okay. So the trick here is understanding how to write this expression in the middle. Okay. You kind of have an idea of what the bounds are, right? The 400 and the 700. But this is what's important because this is what's been changing, right? Before, right, you go back and look at this gallon problem. There were no conditions. It was just like, how many gallons can I get? It wasn't, I pay for the pump one day and then the amount of hours I'm at the pump, like pumping water, that kind of thing. It's different, right? So now we're adding extra things to it. But once it's set up, you know how to solve this. Okay, so go ahead, spend some time, solve it. Tell me what you get. You might get some decimals. It's okay. Turn it into decimals so that you have an idea of how many hours you can really be in that studio. round it to like 2 decimal places. I think most of us have some sort of answer. Okay, you simplify all this good stuff, you ended up with h in the center. What did you get as your maximum amount of time that you could be in sleep? 5.9. 5.94? Okay, so almost 6 hours. Not quite. No. Okay. And what was the minimum amount of time that you could be in sleep? 2.9. Okay, so a little over 2 hours. 2 hours, 10 minutes. Obviously, your graph. Use some decimals here. And since it's an and inequality, we know it should be shaded in the middle. Right? It should be somewhere within that range. Okay. Questions? Okay. And you guys know how to write that using brackets. Okay. All right, let's move on. We've got one more. I'm going to give this one to you, and I want you and your group to work it through it, okay? So you go ahead and flip it over to the back or the next page. It's only going to be one more example. So if you just want to cut your page in half, it's fine. All right, so next one, here we go. Try this out. Okay, I'm going to borrow some people's names here in the room. You guys are going to be my example. All right. Okay, so let's go with Martin. Martin. Okay, wants to figure out how many questions. He needs to get right. On the final, to keep an A in the class. Okay, you guys do this all the time. How many questions I gotta get right? That way I don't have to do all of it. As long as I get those many right, I'm done. I used to do that too, my college finals. Okay. All right. I tell him that he needs to score at least 70 points. Okay. But no more than 88. Okay. He's been doing good enough. You don't need more than an 88. Okay. All right. Each question is worth 4 points. Okay, but something happens. Okay, the day of the final, he shows up late. So that's automatic 10-point deduction right there. Okay, so on the day of the final, all right. Okay, so that's the scenario. Okay, you're gonna write an inequality that models the situation, and then use the inequality and solve it to tell Martin how many questions he needs to get right. So, write an inequality that models this situation. Use it to find the range of questions Martin must get correct. Okay? So go ahead, see what you can come up with. Talk to your partners about how you'll set this up. I'm not going to help you, so don't ask me. When you're ready, get started. Okay, what should you do first before you start? Find the variable, right? What's the variable going to be? What should it represent? P for what? What do we need to know? We know that each problem is worth 4 points. We need to know how many problems he can get right? What range? Okay. So think about that variable, define it. How does the 4 points per problem help you? How does the fact that he lost 10 points for being late affect the equation? Right? I'm starting to see most of you are getting it, so let's talk, okay? Anybody want to share how they wrote their inequality, right? What was the process? How you came to it? Yes. So let's start with your variable. Okay, so hold on, let me unfreeze this. All right, so you wrote Q to represent what? Okay, so the number of questions he needs correct, right? He needs. Okay. And then from there, tell me about your process. 70 on the left, okay. And why'd you make that decision? Okay, at least 70, so that's like your minimum, right? Okay. What else? Hmm. Okay. 88, okay. Put the Q in the middle, okay. So less, okay, between Q and 70, Q is greater than. Okay, greater than, just greater than? Or equal to, okay. Okay. 4 next to the Q, like plus 4? Times 4, okay. 4 times Q, okay, why did you choose to do that? Okay, okay. Okay, and then you put minus 10 inside here, right? Okay. Why the minus 10? He got there late, right? So he already starts at a 10-point disadvantage, right? He already got that knocked off. So it's like no matter how many questions he gets right, he's still losing 10 points because he came in late. Okay? All right. Did anybody else get this? Yes? 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 I see heads nod. Okay. This would be the correct setup, okay? So think about it as all of the points I'm going to get from getting those questions right times 4, but I have to subtract 10 points regardless, okay? So now let's start solving, right? We add 10, right? So we add 10 to all three sides. And what does this do for us, like in the context of the problem? Okay, I know it cancels here. Now I have 4Q is less than or equal to 98, which is greater than or equal to 80. Okay, so what's Martin's goal now? Because he came in late. So in reality, his minimum score now has to be 80, and he can't go, well, he doesn't need to go past 98. Okay, so this 10-point adjustment now gets tacked on to like what his minimum score has to be and what his maximum score could be. Okay, all right, so now real simple, we divide by 4. Okay, this will be 20, and this will be 24.5. So let's say he gets like partial credit on a question, he gets 2 points. 24 questions correct and a partial point. Okay, was that too bad? Wasn't too bad? It's okay. Once you find the pattern, it's not terrible. Okay. All right. Let me stop recording.